Hi guys, welcome to Learn Page by Page. I'm Sally. In this video we're going to go over the difference of two squares. This is a topic which nearly all students lose marks on, especially on a GCSE paper, so watch this one. You'll have a question and you'll be asked to factorise. So you could get x squared minus 9, x squared minus 64, 81y squared minus 100. Let's dive straight in. We'll do the first one and then I'll explain the theory. I always think it's better to see a worked example before I go giving you the general format, the general formula. Before we get started, let me introduce myself. I'm Sally. I'm a fully qualified maths and science teacher, and you hear from my accent, I'm from the UK. I teach a lot of international students. I've worked in schools, and now mainly I teach one-to-one and obviously the YouTube channel. So if you find it helpful, go ahead, do me a favour, hit the subscribe. We've got a bit of competition with a lot of AI channels at the moment, and you can hear from my voice. There's no AI in my voice. This is 100% me. So your thumbs up and subscribe would really mean a lot. Thank you so much. So the first one, x squared minus 9. And whenever you see a squared term here, and if that is a squared term as well, so the square root of 9 is actually 3, or plus or minus 3. So if that's also a square term and so is that, and you have a negative sign in the middle, then what you can do is this. You open up a pair of double brackets. The first term, the x squared, you pull an x at the beginning of both brackets, and then the sign, well, because you've got a number here, the sign there will be a negative in one bracket and a positive in the other, and then you take the square root of the 9, and that's 3, and so in one bracket you have a 3 and the other one you have a 3. Now I'll show you how it works, why when we multiply out this we get this. So we're going to use the FOIL method, and if you're not too sure of that, I'll link a video at the end, but the way it works is you multiply everything in the first bracket, everything in this bracket, by everything in the second. Because you've got the two brackets next to each other and there's nothing in between, that's telling us to multiply both brackets. I always like to think that there's an invisible multiplication sign right there. So the FOIL method tells us to multiply the firsts, that's for F, O for the outsides, I for the inside, and then L for last. And when we do that, we get x times x is x squared. And then the second one was x times positive 3. That gave us positive 3x. Then negative 3 multiplied by x, that's negative 3x. And then lastly, negative 3 multiplied by positive 3, that's the negative 9. And hopefully you can see what's going to happen here. When we collect our like terms, and remember, like terms are terms that are like each other. So here is a squared term, these are letter terms, and that's a number term. We can only collect the terms like each other. So we can only collect these middle ones here. And when we go ahead and do that, we're left with x squared, and obviously positive 3x minus 3x, that's going to be 0. So that eliminates those letter terms in the middle. And then you're just left with a number, so minus 9. And that is a classic example of the difference of two squares. Or elsewhere in the world, you might just call it the difference of squares. I'm from the UK and we do say things a little bit differently here. You'll notice my videos, I will try and point out anything that I do notice. But if there's anything you're aware of that we say a little bit differently, let me know in the comments. It's always interesting to hear. So that's that one done. Let's do this one here, the x squared minus 64. If you want to go ahead and try that, do that now, and I'll do it in 3, 2, 1. So x squared minus 64, wasn't it? And that's going to give us double brackets, x in the beginning of both one, and then we've got 64, and the square root of 64, that's going to be an 8, positive 8 and a negative 8. We won't go ahead and do this part. That was just a proof that we did for the last question, but that's unnecessary. But you can see how it pans out. The reason it does this, and there is a rule, and you may want to jot this down, and that is if the first one is a squared term, so a squared for example, and if there's a negative sign and then you've got b squared, that will equal a plus b bracket and a minus b. You might get more advanced papers, proof papers, maybe in A level, where they might ask you to prove y, and that's how you would lay this out. Now let's do the 81y squared minus 100. With this one, this can trip students up because the ones we were working with before, the squared term, the coefficient was a 1. There was no visible value, was there? So we know that's an invisible 1. But with this, we have a coefficient of 81. But 81 is also a square number. So we apply the same principle. We square root that, and then we distribute that across the two brackets. So that would give us square root of 81 is 9, and the square root of y squared is y. That's the beginning of both brackets. And then square root of 100, that's 10. And it doesn't matter which bracket you put the positive or the negative, and that gives you your answer there. There we are, and that should be about everything. Thank you so much for watching. I hope you find that useful, and I look forward to seeing you in the next one. Thanks, take care, bye-bye.